Okay, so in this question, a glass hemisphere of refractive index 4 by 3 and radius 4 cm is placed on a plane mirror, and there's a point object placed on the axis at a distance d from O. If the final image is formed at infinity, and then find the value of d in millimeter. Okay, so here I just try to draw a diagram. Okay, rough diagram. Okay, it is not measured with the scale. You can see here that the rays started from the O point. Okay, I just drew the rays only. Okay, so you can see they're like whatever the rays entering this medium. So there's the first refraction that will take place here. There's refraction on the plane surface, and when it enters, so it will incident on the curved surface. So again there will be a second refraction. Then there's a reflection on the plane mirror. Then again after reflection will be like there's a refraction on the curved surface, and in the end there is a refraction on the plane surface. So overall there are 4 refractions happening. Okay, and one reflection happening. So let's start with the first refraction. So refraction that is happening on the plane surface. So refraction at plane surface. So for this plane surface, the object is at d distance as per given in the question. So we can calculate the apparent depth. So I'm taking this as a v1. Okay, the first position of the object, apparent object. So v1 will be equal to n times d. Okay, because the object is in rarer medium, so that is the formula. So v1 is equal to, we can write as 4 by 3 into d. Now this, let's say this v1 is here. This is the apparent position of the object v1. Okay, obviously greater than d. Now this O dash is the object for the curved surface. So now that ray is hitting this second curved surface. So we'll apply that another refraction type formula, and that is okay. So first of all, like we need to see the distance of this object from this curved surface. So we can see it clearly. The distance of object from the curved surface is basically, so this is our v1 and plus the radius. So v1 plus radius. So u is equal to v1 is this one, so 4 by 3 into d plus r. R is given as 4. D I'm taking as in centimeter right now. Okay, so it will be like 4d plus r is 4, so 12 divided by 3 centimeter. So this is the u, which is the object position, okay, from the curved surface. Now I'll apply the formula refraction on curved surface. So first I'll write the formula n2 by v minus n1 by u equal to n2 minus n1 upon u. Now for this one, that n2, okay, so here the rays hitting this second curved surface, right? So denser to rarer is going. So for me the n2 will be the rarer medium, so 1 by v2, so that is the image position which I need to calculate, minus n1 is 4 by 3. Okay, u I'll take as minus u, because obviously the object is in opposite to the incident light, is equal to n2 minus n1, so 1 minus 4 by 3 divided by r is also negative, again center is opposite to incident light, so minus r. So let's simplify it. So my 1 by v2 plus 4 by 3 u is equal to it is 1 by 3 r. Okay. So this, let's say this is the equation 2, this is equation 1, right? So we got v2, the image from this curved surface. Now after this refraction on the curved surface, the ray will hit the plane mirror. So whatever v2 is coming here, that will be obviously above the plane mirror. So the image will be formed at same distance from the plane mirror. Okay, because the plane mirror and the curved surface both are at the same position, right? So the image from the plane mirror will be formed here at v2 distance, right? That we can assume something. Now this v2, the image, this virtual image formed by the plane mirror, will be the object for the third refraction now. Okay, so again there will be one more refraction, the third refraction. So for that, like, the ray is coming from the rarer to denser now. Okay, entering the medium again. So let's say again refraction, third refraction on curved surface, Okay, so for this one the formula is still same. I'll just put the value directly now. Okay, for this one I'll assume n2 will be my the 4 by 3, and let's say the image distance is v3 now. Okay, after third refraction, minus n1 will be 1, and u this time the u will be considered as positive because this object is virtual object. Okay, and sorry, this will be negative. Sorry, negative it is. Why? Because this is a curved surface, object is here, so we have to measure the distance, so we'll have to go down, right? And the rays are opposite, right? So it will be negative. Okay, so this u is the object, okay, for this curved surface, but okay, but this u is nothing but v2, right? So we can put this u v2 in place of u is equal to, what do we have, 4 by 3 minus 1 upon r, and r will be positive here, right? Okay, so this is the third equation we are getting. Okay, now the thing is like this v3 is the image formed by this curved surface. Now this v3 is the image, will work as an object for this fourth refraction, right? But now the thing is like we know the final image is at formed at infinity. That is only possible on the okay, so there's a refraction on the plane surface. The refraction on the plane surface will form an image at infinity only if object is at infinity. Getting my point here? Because the formula which we use is nd or like d by n, depends upon the rarer and denser. So the value of v3 should be infinity. Then only the object like when we consider this an object, so that will be at infinity. So that the final image is at infinity, right? So based on this one, because the final image is at infinity, so we are assuming that v3 tends to infinity now. So I'm putting this v3 equal to 0. Okay, now when I put this one, so it is like 1 by v2 is equal to 1 by 3r. Okay, now let's take this as a fourth equation. Now we have the second equation, we have the fourth equation, so I'll just substitute this one. Okay, before substituting I need to tell one thing. In from the second equation, this v2 which we'll get here, okay, this v2 will be coming as negative. Yes or no? Because the image, this v2 will be formed above this curved surface, right? So because right, so the sign we are taking, but this v2 will be coming as negative. So when I'll substitute here, so v2 I'll substitute as negative. Getting my point here? So okay, so I'll go to the next screen. Okay, so these are the equations which we got from the previous page. Now I'll substitute here. So 1 by v2 is this one. So I'll just put this value here. So minus 1 by 3r plus 4 by 3u is equal to 1 by 3r. Now we'll go this side. So 4 by 3u is equal to 1 by 3r plus 1 by 3r is 2 by 3r. Okay, so 3 get cancelled, 2 to the 4 cancel. So 2 by u is equal to 1 by r. R is 4 only. So u is coming as 8. Right, now what is u? U will substitute from the equation 1. So u is 4d by plus 12 by 3 is equal to 8. So 4d plus 12 is equal to 24. Sorry, so 4d is equal to 12. So d is coming as 3 centimeter. Okay, I told you in the beginning that d I am taking as a centimeter. So d is coming as 3 centimeter. But if you want to tell the answer in millimeter, so this d will be equal to 30 millimeter. Okay, so this is the answer of this question. I hope you understood. Thank you.